So good morning. Today we will start from chapter 1. Chapter 1, let us have the introduction to our course, introduction to computer networks. Of course, the textbook, it is called computer networking. All right, so here we have the goal of the chapter. Actually, we already know or already feel it called the big, the big picture. Of course, we should already have the big item and big picture first, and then we will go in depth for the individual item or big picture. And how to have it? We use internet as an example. So here we have the internet to serve as the example. All right, and we already have the following. First of all, we have what's the internet, and then what's the protocol. Then we will check the code of the network edge of the network, so network edge and network code. And we already have the performance. To check the performance, we already know how to have loss, delay, throughput. And after that, we go through slightly about the security. All right. And actually, we have a protocol layer before these. So here, about the overview of roadmap, actually, we will have the slide modification to have the correct order later. And of course, finally, perhaps I will go through quickly about the history of the computer networks. Well, to check internet, here we have the first view. It is called nuts and bolts. Well, nuts and bolts, what it means. So you can check it by yourself, but later I will already have the meaning of nuts and bolts. So this one, nuts and bolts, you can check this quickly, what it means. All right, that you have 1 minute to check this. Or maybe a few seconds to check it. So this is the meaning of nuts and bolts. If we want to check it quickly, actually we will check the component. So nuts and bolts, possibly we can think it's the component view. Well, if we want to check components of the internet, then actually you know we have the devices. So first of all, we have devices. All right, so we have devices. And then devices you can share. You can have your own laptop. You can have the cell phone. All right, and you can have, in fact, server. Even for the server, it serves the devices. All right, and this one we can call it's the end systems. And you can call host. And for host or the end system, we can run network apps. All right, it tries to emphasize end system, so we can have a network edge, and we run apps, applications. And how to have the message transferring? We will have packet switches. So of course we need to have the switches, or maybe sometimes we have routers. switches or routers, then we can forward packets. Here we have the term packet. Well, packet actually maybe not the same, but you can think about packet as the package of the data, and then we have a packet, but we call packet rather than package. And of course we have lines here, but the line here we can call links. So we can have communication links. And of course later we have networks. Where we have a network, for example NTUST, we have a campus network. NTU, we have a campus network, and put them together, then we can form part of the network. Also, you can check network of enterprise. So we have a lot of networks. Finally, we can have the simple term later. Internet, how to have the rough definition of internet. We have all the components here, and it is called a network of networks. Right? Because it's the collection of all networks. So we have the simple or rough definition. Internet actually it's a network of networks. Well, here we have the components view, and here we call it nuts and bolts view. So this is the first one. And actually you can check the picture here, right? If we want to find many networks, in fact, we can have mobile networks if we want to use the devices to have the category of a network. We have mobile networks, and we have a home network. We can have an enterprise network. For the core of the network, previously, we didn't have edge. So core of the network, actually we have routers, switches, and of course then we can have internet service provider. We have ISP. So we have many ISP to provide the service so that we can have the exchange of packets and etc. So we have all of these, and of course right now we check the components of the internet. So we have a nuts and bolts view. Well, previously we didn't have this one. And actually if you don't like this one, you can have your own way to check the apps of dictionary, and then you can know some possible key terms for yourself. But from my viewpoint, I think at least I should have these. So I have nuts and bolts view first. Well, we have the way of actually the component view to check the component. And is it possible to have the diverse devices, and so that we have the different functions? Of course, it's possible. And right now, I think you can see this Amazon Echo. It's a device, right? So right now, we check the possible types of devices. It can be Amazon Echo. It can be an internet refrigerator, the second one, and the others. I think we have a lot of devices and allow them to have the function of networking. And so that all the devices can connect to the internet. Well, about this, actually, if we want to have possible of things based on internet, we can code. We have the concept of Internet of Things, and we can call it IoT. So we can have the basic definition of internet, and then if we want to have all possible devices to connect to the internet, then we have in the past, I think it's not a new type of network, but we have a new type of network. It's called IoT. All right, and IoT for daily life, right? And actually IoT for industry. So if we want to have the specific industrial IoT, then we can call IIoT. All right, IIoT, because we have the emphasis of the industry. So we have the industrial IoT. So we have IIoT. Of course, right now it's not the IoT because we have all possible devices, and you can call all the devices can connect to the internet. So simply you can call, we have IoT. Well, so I already have the definition. Internet, we have a network of networks. Well, however, if we want to allow the network of networks to work together, right? To work together, all the devices, can they connect to each other automatically? Of course, no. So we should have some way to allow them to exchange messaging. Normally exchange messaging. So think about the current scenario. Well, all of you stay here. If you want to have some interaction, and also ask you don't speak and don't send messages. So is it possible to have any possible interaction? No, right? So you can speak and you should send message, and then we will have the interaction. Likewise, for the devices, they should have the way to have the communication. So how to have the communication? Here it says we should have some types of protocols. Here, protocol, and later we will already have the meaning, or maybe I will already know the meaning of protocol. We should have the protocol. Protocol says, all right, so if I want to speak in a company, maybe you have the way, the standardized way to speak. Likewise, for the internet, we should have some standardized way to exchange messages. So we should define protocol. A protocol? No, we have many protocols. For maybe this matter, we have protocol 1. There one, protocol 2, and the others, we have many protocols. Well, therefore, we have many protocols, and so that we can code. Protocols are everywhere. If we want to check the real situation where we have the protocol, how about web page? Web page will based on HTTP. HTTP is one of protocols. If I want to stream video, for example, I use YouTube to have the stream video, and then we need to have part of the protocol. And currently we don't have Skype, but Skype serving as a protocol, TCP, IP, Wi-Fi, 4G, 5G, 6G, and even for the internet we have Ethernet. They are protocols. So we have the way protocols are everywhere, and so that we can exchange the messages for the pair of devices. Well, to have the protocol, in fact, you can have, okay, for example, I want to have the communication with him. In fact, we can have our own way to have the types, formats of the way to exchange. So we can have our own way to have the protocol. But just a protocol between I and him, between me and him, right? If we want to have the open way to have the protocol, of course, we need to have the standard. So that's why we will have the internet standards. Why we emphasize internet? Because currently we emphasize the example of networks using internet serving as the example. So we can have the internet standards. For internet standard, where we have the standard, this one. The first one, request for comments. If we talk about standard, actually it should be the first one. And IETA provide draft, DRAF, draft. We will have a draft first. And then if we have the material draft, then we will have the standard. And then that kind of standard, we will have RFC here. All right, so for the internet standard, we have RFC, and then we have the standard there. Well, if it is draft, can we change it? Sure. So here we have a draft initially, then we will have a standard. All right, so with that we have a protocol or maybe standard later so that we can have the way to exchange the messages. Well, if we have a protocol, somewhat like previously we have a component. And also we have the protocol and put them together to serve as a component of the internet. And how they can provide the possible, here we call service. And actually, how we exchange messages and then we can have the different functions. For example, for the real daily life, we can have the message exchange for banking, right? Or message exchange for example, right now, we try to have the video streaming. Or for the others, so of course, we should have the possible service. And possible service based on the protocol to have the message exchange. Well, and right now we try to directly have the way to share service view of the internet. So, how to provide the service? Actually, we can provide web page, we can have a streaming video, or the others. How to do that? In fact, we should have the action to exchange messages. How to do that? We should have the possible programming interface and so that we can exchange messages for all the applications. All right. So we should send and then receive the messages so that we know the meaning and we know how to have the way to exchange. For example, HTTP, how to have HTTP for the server. We should allow the web page on the server share and so that it can be shown on the end devices. So how to do that? Somewhat like we have the file of the current web page transmitted through the internet to the devices, right? And then devices show the content of that file. So we should have the way to exchange. And based on the protocol, how we can do that, we need to have the programming interface allow them to exchange. All right, so how to provide that way to share the message. And here we want to share the way to provide the service. And of course, we have one key term called infrastructure. And in fact, I show the key term using the bilingual manner. So of course, even for Taiwanese, you can know this directly. But if you don't like this one, of course, you can use your own way to share. I let you know previously. So later we will check in detail, but here, data share, protocol further. So protocol, I let you know the way to exchange some messages. How about human protocol? Human protocol, if you want to exchange the message, you can have a problem. What's the time? And you can have, I have a question. And you will have the introduction. So you will have the way to show the possible content. To show that possible content, maybe you think, okay, I'm a freestyle guy. So do not have any limitation. But normally we have some possible reference style or format. Then we will have specific messages sent. and the specific action taken if we send one message, right? For example, for the first question, what's the time? If I have this question, what's the time? Then maybe the receiver will think about, okay, I will check my watch and then respond, right? So we will have the specific messages to be sent and specific action to be taken and the others. Well, for network, for the internet currently, we consider, devices. So devices actually serving as a role of the human. And for the others protocol, similar to this one, all right? And later we have a web page to serve as an example. Well, so previously we didn't know protocol. So how to have a protocol? Because of message exchange, so we should have the format, order of messages sent, and the others. And if we define all of the details, then we code that is a protocol. Well, finally, we have this way to define a protocol. Why we want to define that one? Because we want to have some reference model, all right? Or otherwise, okay, you don't expect, you cannot expect what kind of action you should take if we don't have some reference model, all right? For example, right now, if I don't have any specific topic, I just pose one question here. Is it 10:30? So some of you, if I use the current question, is it 10:30? I don't let you know what kind of question, what kind of question. I just let you have, is it 10:30? What that means. So anyone can let me have your answer about the current question? Is it 10:30? If you have any idea, raise your hands. In fact, it's hard for you to know, right? Because we don't have any reference. I just speak, and so you don't have any possible reference because the first sentence. So it's hard to tell. So of course we should have some reference models specific for machines. We should let them have some reference model and so that they know how to have the interactions. About my question, is it 10:30? Actually, I did have a question. Is it 10:30? So, okay, you talk about time, right? So if I don't let you have the reference one, then it's hard to let you have the possible question. So we should have a protocol. And here, protocol, in Chinese here, some rules are called rules. And if we have the definition in English, this one. All right. Well, protocol, we mentioned protocol many times. And also here, we already have the definition or maybe the meaning of a protocol. So it's really important for the current chapter. We already know, for internet, in fact, we should have a protocol. Only for internet, in fact, we can have a protocol for the network, not the internet specifically. But currently, we use internet to serve as an example. So we already have the IETF standard, right? Because IETF serving as the possible organization to define the standard for the internet. Well, so in fact, we already have a protocol formally and also the meaning. And currently, we still want to explore the details of a protocol. So we already have these. Well, for the current one, conversation, talking about time. Previously, I already have a question. Is it 10:30? So I don't have the possible reference model. So here we have a reference model. If you want to ask some question, of course, you need to have at least the first one. Hi and hi. Why we should have hi? Okay, if I just casually speak towards one direction, or is it 10:30? What's the time? And then you don't think, currently I want to have the message exchange with you. So for humans, actually, we should have a hi to have the possible start of the conversation. Of course, if I say hi, normally you want to say hi to me as well. Of course, okay, you say hi, I don't want to talk to you. It's possible. But if indeed we want to have the following conversation, we should have the start of the conversation, hi. And after that one, maybe you think, why we know it should be the question about time. Maybe you have your own way. Of course, if I simply have the clear question, what's the time? You know the meaning. So you can start since what's the time? And then you will have the possible answer from one of the pairs. And if we have the conversation talking about time, and likewise, how about network protocol? We can use web page. Web page, actually, if we want to know a bit detail, we should have the connection request and connection response, and so that host and server can connect each other. So first of all, we should have the connection establishment. And after that one, okay, we connected each other, then we can have the next possible action. And after that one, we want to have the web page. So for client then send, all right, I want to get the web page. So get file of the web page, and for the server, send the file to the client. And of course, we have many files. Actually, we can have many files through the actions. So that once we have all the files, maybe not once we have all the files, even we have a single one we can show. And if we have all of the files, we can show them together so that you can have the complete vision of the web page. Well, we just want to directly have the example of the human being protocol, and also use a similar way we can have a protocol for the network, or maybe for the internet. Here we have a web page. Of course, it's an example in the internet. And can we have the others? Sure, we have the other human protocols. And actually, only HTTP? No, we have the other. So that's why I want to mention. Human beings, we have, in fact, if we know asking the time, serving as a protocol, and then we have many. And in fact, for the internet, yes, we can have the other protocols. So not a single one. All right, in fact, we have the nuts and bolts view to check the internet. And also, we already have the protocol. In fact, we should have the detail about the service, but this time maybe we don't already have how to provide the service. Actually, later or in chapter 2, we will already have a possible way to provide service. But before that one, I already know we will have attendance checking. So let us check attendance. This one. So for all of you, you need to check this. That you have 2 minutes to finish it. and name and your ID. It's correct, name and your ID. And I will ask TA to collect all of the records here. And I will have the records for you since this week. I think almost stable. So I will have the records for you since today. And in fact, all of you should put your name and student ID on Paul everywhere, so that you have the records stored on the system. Well, not finished. Raise your hands. Well, for you. So for Paul Everywhere, in fact, you can create your own account. And actually, Paul Everywhere allows you to download the app. If I have the possible Paul Everywhere, then you can use your app to key in. So it's easy. Or maybe, all right, you always need to scan the QR code. Today, we already have for 2 minutes, and let me check. Anyone not finished? Try to get it done. Finish it. 1 more minute. So wait for him. So, finish it. So is it okay? Why? It mentioned your name on the screen. Is it correct? So in the future, I won't check any other possible problem. If you have the current problem, you should fix it. So, is it okay to let me move on? All right, so maybe you can send one message on our line group. Your name and your ID for attendance checking, because I cannot wait for you anymore. So let us continue. And currently we already have what's the internet, what's the protocol. All right. And right now data check network edge. That says we can have the host. And actually we have a media. And of course, for edge we have the access network. So we have the actual one access network. Well, we just have the nuts and bolts view. And right now we want to check edge. So we can have, of course, we can have devices that says host. And host, actually we can have clients, servers. Well, server? In fact, yeah, server. Server serving as part of host. So we have servers. And actually, server actually right now, in fact, we can have one server. And if we have a lot of servers, then they can form the center. So we have data centers possibly. And because we allow the host to connect to the internet, of course, we need to have the access network. And for the access network, how to access the network, we should have the physical media. And physical media, previously we have links. And here we call, we have physical media. And we may have wireless communication links, or of wireless communication links. They serve as the media. And so that we can connect the host to the internet through the network code. And where we have a network code, we have a router switches. And previously we simply call switches. In fact, we may have a similar function but different layers. For switches, actually we call it's the layer 2. Layer 2 device. What it means, layer. Later we already have a protocol layer. And here we have routers. Actually, it is layer 3. So layer 2 or 3, later we will already know that. But right now, I just mentioned we can have switches, routers. All right. And if indeed we care about code, here, yes, we care about routers because switches may be here, but router within the code. So it's true, we can have a network code only interconnected routers because previously we don't mention routers. So that's why I don't have the similar components. But here, network code, we care about routers. And of course, we have a network of networks because here, yeah, network. Even we don't have in fact, even we have the whole network, enterprise network, but network of network, we care about the inner side of the internet. So we have a network of networks. Maybe let me mention some in Chinese. 我前面讲的 switch 和 router。Switch 是第2层的 ，router 是第3层。那现在因为讲的是网络核心，所以我们就当然没有把比较属于边缘的 switch 把它纳入，所以就讲这 router。啊，你当然觉得奇怪，前面为什么讲 switch， 现在为什么是 router？Alright, so I have a bit way to explain routers here rather than switches. Alright, so we have these. Well, we have media, and here we have one question. How to connect any system to edge router? Here we call edge router. Maybe for this one, it is not the router, but it can be Wi-Fi AP. We call they are switches. But beyond this, then we have a router, and we call edge router and the other routers as well. So how to do that way? We may have residential access networks. We may have institutional access network. We may have a mobile access network. But why we have all of these? Because different way to access the network. For example, for mobile access network, we can use Wi-Fi. So what that means, Wi-Fi, we should have some standard so that allow us to have the Wi-Fi to access. And we can have a cellular network. We have a 4G, 5G, or even 6G in the future. And institutional, school and company, we use Ethernet directly. And residential, how to have the access, maybe we rely on mobile communication network so that we can have the access. Or maybe we don't pass on that one. Maybe similar to institutional access network, we still have the fixed network. Well, so these are all possible networks, access network we can have. And so how? In fact, we have the possible standard and protocol. So we can pass on the possible standard and protocol to access the network. Well, to access the network, then we may have the further question, transmission rate. So what's maybe it doesn't mean the speed, but someone like, oh, okay, similar to the meaning of speed of running. And likewise, transmission rate, we want to feel how fast or how slow it is. So we have the transmission rate higher than we have the fast transmission rate. And so that you will feel, okay, take maybe a short time to finish the transmission. And lower, and then you should have a longer time. So this is the transmission rate. And transmission rate is somewhat like the capacity of the link. And also, we care about, well, if I can access, can the other people access? If yes, then possibly we should share the transmission rate. Or maybe no one should share with you. And then we have the dedicated capacity. So if you have the way to access, you should care about the transmission rate. And also you will care about, should I share with the others or we have the dedicated one? Well, shared and dedicated one. If we talk about the price you need to pay. Share, of course, you pay a bit. However, dedicated one, you need to pay more, right? So of course, based on the price, we will have a share or dedicated one. Why? Why we want to have all this? Because sometimes some special customer want to have the dedicated one, and then we can let them do, but we need to ask them to pay more. Or otherwise, if we want to have the cheaper solution, then we may have the share one. And based on the feature, share or dedicated one, in fact, we can have the different price. Well, here we just want to let it have a bit more details if we have the access network. Here, we let it have a home network. Previously, we have a home network, institutional, actually it's called residential, not home. But home or residential network, this one. First of all, we can use cable. And here we have a cable. All right, this is cable. And why cable? Then we have all of this. It says we have a cable. Cable can carry carry multiple video or maybe data or maybe the control signal. So we have a channel 1, 2, 3 and maybe many channels. It doesn't mean just 9 channels. So we have multiple channels to carry different video or the others. So we can have a cable, and this is a component. We have a laptop, we have our PC. So how to connect to the internet? In fact, you can plug in and then we can send messages. And you can have Wi-Fi, so you should have AP modem, so we can pass it to the internet. And we have a cable, so you have the other, and so that tells this direction to the cable head end. All right, so we can have somewhat like a collector, and that collector here we call cable head end. So this is a way to have the possible residential access network. And actually, we can have channel 1, 2, 3. So here we have simply we call frequency division. And frequency division to put them together. So we have multiplexing. So different transmitter transmitted in different frequency band, but it's a single cable. And a single cable to carry all of them. And this function we call multiplexing. And currently we pass on frequency to have the multiplexing. So we call FDM. And we already have the term here, multiplexing. And also English to explain multiplexing. So we can have FDM, and so that we can allow all of users to send using different channels. So if we have a lot of users to use, and then we need to increase. So talking about transmission rate, increase. Of course, we should have a larger transmission rate, but finally, we should have a fixed one. So we will have the capacity there. So transmission rate, capacity, we may think they are identical one, but we have a limitation set to the capacity because we cannot always have unlimited capacity. So we should have the limited capacity. So we have the limited transmission rate. And based on the previous frequency division, we know we want to send data. For example, you want to send a file, and video, TV, and the others. And you should know, we put them together, we share the cable capacity. And to this one, and then we call cable modem termination system. So that's why we have a CMTS. All right. And later we will continue. Well, up to now, any questions? If no, take a rest, and later we can continue. Okay, take a rest.